Welcome back. Today we're going to take a look at slopes of secants and average rate of change. I'm hoping that you remember what the word slope means when it comes to straight lines. If you don't know what a secant is, that's okay. We're going to cover that in the lesson. So let's go over and take a look at what we're actually doing today. We're going to start off with what hopefully is a very, very easy exercise. I've given you 4 lines there, and I'd like to see if you can tell me the slope of each. If you'd like to pause at any point, this is true in any of the videos, and try these on your own before I answer them, by all means, be my guest. If not, that's fine too. Okay, as hopefully you remember, slope is just a rise over a run. So how far does it go up divided by how far does it go over? Now the easiest way to do this is to go over 1, because when we go over 1, rise over run becomes rise. So as we went over 1 here, we went up 1. That means our slope, which we usually denote with an M, is 1. Over here, as we go over 1, we go up 2. Our slope is 2. Here we go over 1 up a half, or over 2 over 1. Either way, 1/2 over 1 or 1 over 2 gives us a slope of 1/2. And here you can go over as far as you want. You're never going up or down, which means that your rise over run is always going to be 0 over something, or 0. So it represents a flat line. Now what I want to try and get into your mind is that the idea of slope really, really makes sense when you're talking about straight lines, but the idea of rate of change applies to all kinds of graphs, including curved ones like polynomial functions, exponential, sine, all that stuff. So we're going to try, when at all possible, to use the term rate of change rather than slope. That doesn't mean we'll get rid of slope, but we're going to try and beat in that it is a rate of change. And I should point out that a rate of change, I mean, it's not just a different word or a different phrase that we use to mean the same thing. It actually is a rate of change. So for instance, if you go 60 kilometers in 2 hours, your rate of change is 60 kilometers per 2 hours, or 30 kilometers per hour. 30 kilometers per hour is a rate of change. It's telling you how fast you're changing your displacement. So the phrase really does make a lot of sense in most real-life contexts. Define the rate of change for a curve, or the slope of a curve. Now, when I say slope of a curve, most people are a little confused. They're like, well, it's not a line. How do you find a slope? And the answer to that is we find a secant, or a straight line segment that connects 2 points. If we connect 2 points, we can find the average rate of change between 2 points. We cannot find the average rate of change at a point. That doesn't really make sense. There's a bunch of text there. You're welcome to read through it if you like. Otherwise, we're just going to kind of jump to the graph. And you'll notice that the homework thing's already on the bottom, which means we're already to the bottom of the page of this lesson. It's pretty awesome. Okay, the first one. Let's use secants to find the average rate of change of a function, f at x equals x squared, which is the one graphed there, between each of the following sets of points. By the way, these are the x values. So the first one we're going to look at between x equals 0 and x equals 1. Now if I connect those with a straight line, or a attempted straight line anyway, I can see that the slope is going to be 1 over 1 is 1. Now I can do that in a couple of ways. I can do it more formally. If you'd like, I'll do it on the first one anyway, just to give you an idea. Rate of change should be the final value minus the initial value, which in this case, since we're f at x equals x squared between 0 and 1, the rise is 1 squared minus 0 squared over the run, which is 1 minus 0, which is 1 over 1, which is 1. Yeah, I think it was easier just to look at the graph and figure that out. Between points 1 and 3, now this goes over quite a bit. To go over 3, we're already over here. And where's across the graph? Up there at 9. I mean, that makes sense. We go over 3, we go up 3 squared. So the secant between those 2 points, it's going to be tough for me to draw a straight line here. But something like that. That's the messiest straight line ever. But that connects those 2 points, and that tells us, or that is the secant, and it's going to give us the average rate of change between, oh, oops, I went between 0 and 3. Now I have to fix it. I'm going to cheat a little bit. Yeah, that's it. I erased the whole thing. I want to go between 1 and 3. You know what? There isn't. Let me try this on here. There is an actual fanciness. I don't know how well this is going to work, but we'll give it a shot. I think that looks pretty good. Okay, so there we have a straight line between 1 and 3. And between 1 and 3, we went over 2 and up 8. So our slope's just going to be 8 over 2 or 4. Okay, what about negative 1 and 3? So that's the point here. And I'm going to pull out my ruler again since it worked so well the last time. And draw my straight line. Okay, this time we went over 1, 2, 3, 4 and up 8. So rise over run. And our slope of that line is 2. Which is actually easy to verify. If we look at this, we go over 1, up 2, over 1, up 2, over 1, up 2, etc. Okay, I'm going to do this for the rest of these, really try to do them fairly quickly. Between negative 1 and 0, the straight line looks like it goes down 1. Between negative 3 and negative 3 and negative 1, negative 3 to negative 1. Yeah, I need to use the ruler for those. Negative 3 and negative 1. It's almost too time consuming to bother. But proper is proper. And from there we went over 2, down 8. So negative 8 over 2 is negative 4. And from negative 3 to negative 1, negative 3 to positive 1. We have that line. And that goes down 8 over 4. By the way, you don't even have to draw the lines. I mean, you can just look at the values. But down 8 over 4 gives us negative 2. I'm just going to point out here that I chose these numbers in particular. There's definitely some symmetry going on in a parabola. The slopes on the left-hand side are the exact opposite sign of the slopes on the right-hand side. Whatever the slope is going down on the left, it is the same thing going up on the right. Okay, now the last ones. These ones are going to be kind of easy. I'm going to leave it on green. If we want to do the slope between negative 1 and positive 1, that's a flat line. That's just 0. Between negative 2 and positive 2, 0. And between negative 3 and positive 3, 0. And if you think about it, that makes sense because the values are the equal height on both sides because of the line symmetry or the fact that it's an even function. So as long as we're going between a value and its negative value, the slope, average slope, or the average rate of change should be 0 between those. That's pretty much all there is for secants. So I'm going to let you try some of those homework questions on your own, and then when we come back, we'll take a look and see if there's any of the questions that you'd like to take up from those, if that happens. Anyway, enjoy your short lesson for the whatever time this is, week, day, month, whatever you're doing today, and we'll see you next time. Bye.